Okay, guys, we are back in the same packet that we were on Monday. We are still in Unit 10, packet number 1. Okay, if you want to get that out. And again, that was the packet that was attached on Monday, and I've attached it again today to EduFlow. And if you don't have a printer, well, I would recommend printing it out. If you don't have a printer, you can go ahead and you can just take notes in your notebook. And we are going to be on page 8 today. Okay, so starting on page 8. Okay. I'll write that at the top too, in case you can't see. We are on page 8. Okay, today we're going to talk about multiplying radical expressions. It says to multiply and simplify the following radical expressions. Okay, you are going to multiply what's under the radical symbol. So 6 times 18, okay, is going to give you the square root of 108. Okay, and if you can use your calculator, or if you just know, that breaks down to the square root of 36 times 3. Okay, we know the square root of 36, that's a perfect square, so it's 6 root 3. Okay, if you would have wanted to, you could have done that a different way. You could have done root 6, and you could have done times 9 times 2, the square root of 9 times 2, because we know that 9 is a perfect square. You would have gotten square root of 6 times 3 root 2. Okay, then we would have multiplied, and we would have gotten, you just multiply what's under the radical sign. 6 times square root of 6 times square root of 2 is square root of 12. Okay, that would have given me a 4 times 3. Pull out my 2. That would be 6 root 3. And that gives you the exact same answer. Okay, so either way is fine. I really don't care how you do it. Okay, square root of 5 times square root of 30 is going to give me the square root of 150. I hope you can see that that's 25 times 6. Okay, the square root of 25 is 5. We pull the 5 out. 5 root 6. Not that difficult, okay? Now we're just going to get a one step harder. Here we have the square root of 5, and it's times something inside parentheses. So we need to make sure that we distribute, okay? You're going to distribute to everything, to each term inside. Square root of 5 times 4 is 4 root 5, okay? Minus square root of 5 times square root of 20 is the square root of 100, okay? You can see that that's a perfect square, so we've got 4 root 5 minus 10. And I always put the term with the radical last, so I'm just going to switch the order here. Negative 10 plus 4 root 5, okay? So make sure you remember rational number first, okay? And that's my rational. So I put my rational number first. I put my number with my radical second. Okay, we are on letter D. Okay, square root of 6 times 7 root 3 plus 6. Again, this is distributing. Okay, we're going to take square root of 6 times 7 root 3, and that's going to give me 7 root 18. Okay, and then we have, let's see, square root of 6 times 6. That's going to give me plus 6 root 6. Okay, I can see a perfect square inside there. So I've got 7 times the square root of 9 times 2 plus 6 root 6. I can pull out my 3 there because the square root of 9 is 3. 7 times 3 root 2 plus 6 root 6. That's going to give me 21 root 2 plus 6 root 6. Nothing else we can do on that one. Okay, let's do a few more. I think we're going to skip this one. You guys get the idea on that. Okay, we are going to skip to F, and you can see that we have 2 terms times 2 terms, right? So we're going to have to use our friend FOIL. Okay, so we're going to take the first 2 terms, which is 2 times 2. That's going to give me a 4. We're going to do our outer terms, which is 2 times the negative square root of 5. So we're going to have minus 2 root 5. We're going to do our inner term, which is 2 times the square root of 5. So plus 2 root 5. And then we'll do our last terms, square root of 5 times square root of 5. And there's a minus there. So minus square root of 25. Okay, let's do some simplification. There's 4. Negative 2 root 5 plus 2 root 5. That cancels. And we're left with minus the square root of 25, which is minus 5, which is going to give me an answer of negative 1. Okay, that was kind of a fun little problem. Let's look at Letter G. Okay, we've got, again, a FOIL situation here. 4 times 4, 16. Outer. 4 times negative square root 3, that's going to be negative 4 root 3. Inner, plus 4 root 3. Last, minus the square root of 9. Okay, we've got 16. Look at these two. They're opposites. They cancel. And then that's minus square root of 9, which is minus 3. So we get an answer of 13. Okay, now we could see that those were opposites of each other, right? Here we're going to have one where it's the same, right? We're going to take this term times itself. So here we have to write it out. We're still going to use FOIL, but first write it out. 3 root 5 plus 7 times 3 root 5 plus 7. Okay, now we just do the same thing with our FOIL. Okay, we've got 3 root 5 times 3 root 5. 3 times 3 is 9. Root 5 times root 5 is root 25. We've got our outer. Let's see, 3 times 7 is 21 root 5. Inner is plus 21 root 5. And our last is plus 49. Okay, let's see what we can do here. Well, we have a perfect square, so that's going to give me 9 times 5. Plus, we have a 21 root 5, 21 root 5. Those are like terms. So we've got a 42 root 5 plus 49. 9 times 5 is 45. I'm writing out all these steps just so you guys can see that. And then we've got some like terms here. 45 plus 49 is going to be 94 plus 42 root 5. Okay? Let's see where else we're at here. I'm just looking to see in my notes what else I want to get through today. Okay, let's flip to, let's do one more. I'm going to switch colors though so we don't run together. So I kind of went over. Okay, again, we need to use FOIL. Okay, first two terms. 2 times 8 is 16. Outer, 2 times the negative square root of 6 is going to be minus 2 root 6. Inner is going to be 8 root 6. And outer is going to be minus the square root of 36. Okay, so let's do some simplification. We got 16. We have a square root of 6, square root of 6. So those are like terms we can combine. Minus 2 plus 8 is plus 6 root 6. And then the square root of 36 is 6. 16 minus 6 is 10. Plus 6 root 6. Okay, so just to reiterate, when you have like terms, it's when the number under the root, when they're the same. Okay, that means you have like terms. Okay, if those two roots were different, you could not combine them. Okay. Okay, let's go ahead and go on page 9. Let's see here. We're on page 9. For those of you who are having a hard time seeing this. And the first one, multiply and simplify the following radical expression. The square root of 5 plus 2 over square root of 7. Well, we know that we cannot have, we talked about rationalizing the other day, the denominator. We cannot have a square root in the denominator. So we multiply the top and the bottom by 7. Okay, that's good. Now, think of it like this. Everything's in parentheses. You have to multiply that square root of 7 times everything. So we're going to get the square root of 35 plus 2 root 7 all over the square root of 49. Okay, let's see. Square root of 35 can't be simplified. Nope, that can't be. This is going to become a 7. I always go in order from least to greatest. What's number under my radical sign? So we're going to start with 2 root 7 plus the square root of 35 all over 7. And I don't think that can be simplified any further. Nope. Okay, let's see what we got here. You can do this one a couple different ways. I can see right away that 12 has a perfect square in it. So I'm going to say square root of 2 plus 5 over 4. And that's 4 times 3 under my radical sign. Okay, that's going to give me a square root of 2 plus 5 over, you can pull out a 2, so 4 times 2 is 8, root 3. Okay, now I cannot have a square root in the denominator, so I have to multiply both the top and the bottom times the square root of 3. And if you think of it like this, you can think of that in parentheses. You're multiplying everything. So square root of 2 times square root of 3 is square root of, sorry, I'm just thinking this through, square root of 6 plus 5 root 3 all over 8 times square root of 9. Okay, that's going to give me a 3. So I've got square root of 6 plus 5 root 3 all over 8 times 3, which is going to give me 24. Okay, the only thing I would say is that I always look at what's under the radical sign and I go from least to greatest. So I'm going to say that's 5 root 3 plus root 6 all over 24. Okay, and that's how you would do that type of problem. Okay, let's go down to, I think what is going to be our last topic. Oh, almost. We have a couple more topics. Okay, we are on adding and subtracting radical expressions. And this isn't really any different than what we've been doing. You're going to add or subtract radical expressions. The radical expressions must be like terms or factored to like terms. Okay, so if you look at that, there's nothing we can combine yet. That's a radical 7. That's a radical or square root of 63. Those are not like terms. But watch what happens when I pull out a perfect square. 2 root 7 plus 3. We know that's a 9 times 7. That's my perfect square. I get 2, put this back a little bit. I get 2 root 7 plus 3. Pull out that times 3 root 7. 3 times 3 is 9. 2 root 7 plus 9 root 7. Now I have like terms. Think of it as when you have an x and an x. When you have the square root and the same number under the square root, that means it's like terms. 9 plus 2 is 11. 11 root 7. And there's your answer. Okay? We go to a little bit of a harder one. Actually, this isn't that hard at all. We can see that we have 2 like terms because of that 5 and that 5. So 7 plus 4 is 11 root 5 minus the square root of 11. 5, there's no perfect squares inside of. 11, no perfect squares. We're done. That's all there was to that one. Okay? Going down to letter C, we've got 7 root 14 plus the square root of 21 minus 4 root 14. Oh, well, right away, I see some like terms. 7 minus 4 is 3. 3 root 14 plus square root of 21. No perfect squares in 21. I'm done. Okay, look at D. We've got 7, we've got 14, and we've got 28. Well, 7, no perfect squares. 14, none. Oh, but look at that one. We have a 4 we could pull out. So we're going to do 3 root 7 minus 5 root 14 plus 2 times 4 times 7. Okay, that's going to be square root of 4 is 2. So I've got 3 root 7 minus 5 root 14 plus, pull out a 2. 2 times 2 is 4. 4 root 7. Now we've got some like terms. We've got a 3 and a 4 because it's root 7. So that's 7 root 7 minus 5 root 14. Okay. So again, I think these are kind of interesting problems to do. I think they're kind of fun. I think once you get some practice in, you're going to find that you get the hang of these. Let's go to page 10. Okay, and we are going to do, oh, we just did this one. This is the same as previous page, isn't it? Let's do letter F. Okay, this is a mess. Let's see, we have no like terms yet. Perfect square there. Let's pull that out. Negative 4, 9 times 6, minus 3. Oh, another perfect square, 4 times 2. Minus 2, root 5, we can't do anything with. Plus 3. Oh, we got a 16 times 2. Okay, so a 9 times 6, that's going to give me a 3. So that's going to be negative 12 root 6. Then we've got minus, let's see, pull out a 2, so minus 6 root 2. Then we've got a minus 2 root 5. And let's see, we pull out a 4, we've got plus 12 root 2. Let's see if we have any like terms there. Oh, we have a minus 6 root 2 and a plus 12 root 2. That's going to give me a 6 root 2. So we've got negative 12 root 6 plus 6 root 2 minus 2 root 5. Okay, now remember I said put your radicals in ascending order. So we're going to start with the 6 root 2. Then the next biggest is minus 2 root 5, and then minus 12 root 6. And there's my answer. Okay? Let's see. Let's turn to page 11. Okay, let's go to page 11. And, okay, there we are. And I can hear my kids. I hope you can't hear them. They're screaming. They're playing a basketball game downstairs inside on the basketball hoop we have hung in our kitchen right now. And they are being very loud. So I apologize if that's bugging you because it's really bugging me. Okay, this is a super, super tricky problem. This letter H on page 11. Okay, let's see if we can do it. 2 root 6 over root 30 minus 3 root 20. Okay, I'm not going to lie. This is super tricky. Okay, I can see right away that I have a perfect square here. So I'm going to do 2 root 6 over root 30 minus 3 over root 4 times 5. Okay, I'm going to pull out my 2 right away. Okay, so I've got 2 root 6 over square root of 30 minus 3 over 2 root 5. Okay, now I'm going to go ahead, and I can't have a square root in the denominator. And these are not like terms, so I'm going to go ahead and multiply top and bottom by square root of 30. And over here, I'm going to multiply top and bottom by the square root of 5 over square root of 5. Okay, that's going to give me 6 times 30 is 180 over the square root of 900, which is 30. Okay, minus 3 root 5 over, that's going to give me the square root of 25, which is 5 times 2, which is 10. Okay, so far so good. 180, I know that I can pull out 36, so I've got 2 times 36 times 5 over 30 minus 3 root 5 over 10. That's going to pull out a 6. 2 times 6 is 12. 12 root 5 over 30 minus 3 root 5 over 10. Now, this is where it gets tricky. Some of you are going to want to leave it like that. I see that I could get a common denominator of 30 by multiplying the top and bottom by 3 over 3. Let's get a common denominator, okay? So I've got 12 root 5 over 30 minus 9 root 5 over 30. And that way I can simplify this down as much as possible. 12, I have a common denominator. These are like terms, so I can do 12 minus 9, which is 3 root 5 over 30. And look, I can even go a step further. Those 3's cancel, and then I'm left with root 5 over 10. And there's your final answer. Okay? I promise we are in the home stretch. We just have like 2 problems left, and then we are done for the day. Let's go to page 12. And the last thing that we're going to talk about is conjugates, okay? And when you're talking about a conjugate, let's just talk about the idea first. The idea concept is to multiply what's in your denominator, okay, 2 minus square root of 3, by its conjugate to get the middle in the denominator to eliminate or drop, okay? So if you have 2 binomials, 2 minus square root of 3 and 2 plus square root of 3, those, see how they have opposite signs, are called conjugates. Okay, they're called conjugates. And remember to multiply, and we're going to talk about this after I'm done writing, both the numerator and the denominator by the conjugate. So look up here. If I'm looking at 9 over 2 minus square root of 3, I want to get rid, that's a binomial, right? 2 terms, binomial. I want to get rid of the middle term in the denominator. So if I take it times 2 plus the square root of 3 and 2 plus the square root of 3, those middle terms, like, see that? That's going to go away, okay? And you'll see in a second here what I mean. So let's look down here. 1 over the square root of 7 plus 1. Let's change the order first. Let's do 1 over 1 plus the square root of 7. Because remember, I always put my rational number first, okay? If I want to get rid of that square root of 7, I can multiply by the conjugate, which is 1 minus the square root of 7 and 1 minus the square root of 7. Okay? On top, that's going to give me 1 times 1 times, so that's just 1 minus square root of 7. On the bottom, I'm going to have to use some FOIL on the bottom. 1 times 1 is 1. Okay, I've got minus the square root of 7 plus the square root of 7 minus the square root of 49. Okay, that's going to give me 1 minus the square root of 7 over, those cancel. So now I'm left with 1 minus 7. So I've got 1 minus the square root of 7 over negative 6. And I know some of you are going to want to leave that, but I never leave a negative in the denominator. So I'm going to multiply the whole thing by negative 1. And I get, what, negative 1 plus the square root of 7 over positive 6. That's the same exact thing, okay? Those two are equivalent. Okay, they're equivalent to each other. Whew, okay, we're in the home stretch here. Look at letter B. Okay, square root of 10 over 7 minus the square root of 2. We have a binomial in the denominator, and I want to get rid of that square root of 2. So I'm going to multiply both the top and bottom by the conjugate, okay? That's going to be 7 plus the square root of 2 and 7 plus the square root of 2. Okay, on top and bottom, you have to do it to the numerator and the denominator. Here I'm going to have some distributive property. 7 root 10 plus the square root of 20 all over. Okay, now we're going to have to do FOIL on the bottom. 7 times 7 is 49 plus 7 root 2 minus 7 root 2 minus the square root of 4. Okay, that's going to give me 7 root 10 plus, oh, I see that I have a perfect square there. I'm just going to pull it right away. 4 times 5 all over. What do we got? These cancel. That's a 2. So 49 minus 2 is 47. Okay. We've got a 7 root 10 plus 2 root 5 over 47. Can't get any simpler than that. Okay, so using the conjugate is going to be a good way when you have a binomial in the denominator to get rid of that square root, okay? Let's do just one more together, okay, and then we'll be done. You look at page 13, and we're on letter E, okay? You can see that we need to multiply by, we have a binomial in the denominator, so multiply by the conjugate of what's in the denominator. 3 minus root 3, 3 minus root 3, okay? We're going to have to actually use FOIL on top and bottom, right? FOIL on both. So 3 times 2 is 6. Outside minus 2 root 3. Inner plus 3 root 3. Last minus root 9. We're going to do FOIL on the bottom. 3 times 3 is 9. And the whole purpose in getting that FOIL or getting that conjugate down there is to cancel out the denominator or the radical. So 3 times 3 is 9, minus 3 root 3, plus 3 root 3, they cancel, minus square root of 9, okay? Here we've got some like terms, it looks like, and this is going to give me minus 3. So 6 minus 3 is 3. 3 minus 2 is 1, so plus root 3 all over 6. And I can actually simplify that even further, really, and what's equivalent to that. Those, you can break that up, 3 over 6 plus root 3 over 6, and that's going to give you 1/2 plus root 3 over 6. Okay, and I think that is plenty for today. You can get some good practice in, and hopefully we will revisit this next week, okay?